This is GlobePharma's MiniPress II Tabletop Rotary Tablet Press. I will discuss the features of the machine first, followed by the safety features, and then we will go to actual demonstration of the machine, and we will also run tablets, and I will show you how the machine runs. MiniPress II comes with 3 different types of turrets. A 10-station B tooled turret, which is B like boy, or 8-station D tooled turret, D like dog, and a combination turret with 5 stations B and 5 stations D. The turret is made of 316 stainless steel. That is the only option we have on this machine. And on another machine, which I will show in a different demonstration, on MiniPress 1 we can get electroless nickel plated turret. But MiniPress 2 comes with 316 stainless steel turret. The turret has keyed head, so you can use round tooling or shaped tooling. And the turret has AC drive with fixed pulley, and it has a thrust bearing. The upper punch cam track is made of a single piece, so there would be no problem with the punches riding on the cam track. The turret has a variable speed drive, and the machine can be run anywhere from 3 RPM to 36 RPM. The machine has 3-ton maximum compression pressure and 1-ton maximum pre-compression pressure. The compression and pre-compression rollers are heat treated, and they're very hard in strength. The lower punches are provided with seals so that the powder doesn't get inside and bind the punches. The lower punches also are provided with nylon retaining plugs so that in round punches, the punches wouldn't have a chance to turn around during compression. If the punches are allowed to turn, if there is no logo or any type of markings or a bisect on the tablet, it would be okay. But if it is a marked tablet like a logo or a bisect, then you don't want the lower punch to turn during compression. Otherwise, you will get double impression of the logo or something like that. In cases like that, the lower punch retaining plugs would be very useful. Now, the machine comes with 2 different types of feeders. One is a gravity feeder, which is on the machine right now. Another one is a force feeder, which I will show to you later on installing on the machine. And each feeder has its own hopper. So the machine comes with 2 feeders, a gravity feeder and a force feeder, and 2 hoppers. And the force feeder has variable speed controls here. We will show you in detail during the demonstration of the machine. The weight control of the tablet can be done using this knob here. And pre-compression can be adjusted using this handle here, and the hardness of the tablet can be controlled using this knob here. The main power switch on the machine is here. I would like to explain some of the safety features on this machine. All the doors, all the 4 acrylic doors on the top and all the stainless steel doors at the bottom, they all have safety interlocks. So if you happen to open any of these doors during operation of the machine would immediately stop. In general, a tablet machine is a dangerous machine. You have to exercise a lot of caution when you are operating or cleaning the machine. Whenever you are operating the machine, make sure all the safety guards are in place and they're interlocked. And when you are cleaning the machine, make sure you unplug the machine and only turn it by hand. And here we have a hand crank wheel to turn the machine by hand. And that wheel is also enclosed in an acrylic enclosure, so that if it happens to turn during running of the machine, at least it would be contained within this enclosure. It has a key, so when you want to turn the machine, you have to press the hand wheel inside and then you turn the turret by hand. The specifications are, as I said before, compression pressure is a maximum of 3 tons. Pre-compression pressure is a maximum of 1 ton. And with B tooling, B like boy, you can make a tablet with a maximum diameter of 16 millimeters and a depth of fill of 17 millimeters. And with the turret can be run from 3 to 30 RPM, and you can get a maximum output of 21,600 tablets per hour if you run at the maximum speed. With a D tooled turret, D as in David, you can go to a maximum diameter of 25.4 millimeters and a depth of fill of 20 millimeters, and you can actually get a maximum output of about 17,000 tablets per hour. If you use a BD combination turret, then of course you're using only 5 stations, either B or D at a time. So if you're using the BD turret, we will be providing 2 sets of cams, one for B, one for D. So you have to switch the cams, the upper cam track, the lower cam track for B and D. You have to switch those, and it is not difficult to do that. It will take probably 15 minutes or maybe at the most half an hour to switch from B to D. When you are using B, you have to blank the D die cavities. When you are using D tooling, you have to blank the B die cavities. And now we will actually go to showing all the parts of the machine in detail, and then I will show you how to actually tool the machine, how to run it, and then how to take everything apart and clean it. MiniPress II can also be instrumented with load cells to monitor compression force, pre-compression force, and ejection force. This machine right now has those load cells already installed, but the load cells have to be connected, of course, to a computer and all the software for instrumentation. In this particular demonstration, I'm not focusing on instrumentation. That will be a separate demonstration. We are coming up with a new software package which can be used with just a laptop computer with a USB port, and as soon as that is available, we will make a DVD of that instrumentation and send it to you. The MiniPress II is a GMP design. So it is easy to clean, easy to set up, easy to use. It is an ideal machine for R&D, formulation development, as well as for making pilot batches for clinical studies, things like that. Now I will identify all the individual parts of the MiniPress II tabletop rotary tablet press. This is one of the 4 acrylic doors that have magnetic interlocks. And the door lifts up like this, and then it will, once it is lifted up, it will stay in place so that you can do any maintenance work or cleaning work on the machine. The magnetic interlocks are here, and each door has 2 of them. This here is the hopper for the gravity feeder, which is here, the gravity feeder. And inside the enclosure here, there is a gear motor that is used to control the speed of the variable speed force feeder. And this here is the upper punch cam track. And these are the upper punches. And this is the upper punch table. And here there are upper punch bores with keyway. So you can use keyed punches also. And this is the die table. These are the blank dies. On this machine, even though it has 10 stations, we are actually using only 5 stations for demonstration purpose, which means we are using 5 blank dies. There is a die lock screw here, and that is the one we tighten to keep the die in place. This is the gravity feed frame, and this brass scraping bar is the one that levels the powder once the die goes underneath that, and that is the one that removes any excess powder from the die. And there is, these are the 2 knobs that we use to keep the gravity feed frame in place. This here is the stand for the feed frame, which is pretty much in a fixed place. And the height of this can be fine-tuned by using thin stainless steel or any plastic shims. And this here is one of the 2 turret guards. This is the other half, this is the first half. And inside these turret guards, we have the lower punches, which are inserted into the lower punch table. And each lower punch has a seal, as I mentioned before, that prevents the dust from binding the lower punches. Now I will remove the lower die table turret guards and show you the lower punches and pre-compression roller, ejection cam, lower punch pull down cam also. The turret guard has 2 segments, as I mentioned before, and each segment is fastened to the middle plate of the machine by 2 thumb screws. By removing the thumb screws, we can remove the 2 parts of the turret guard. This is the thumb screw. I will show you one of them. And I removed the other 3 already, so we can now remove the this is one half of the turret guard. I already removed the other half. Now we can see all the parts that are inside the turret guard. I will show them to you. This here is the lower punch table, and this here is one of the lower punches we already installed. This here, the black plastic seal here, is the lower punch seal. This here is the spring lock for lower punch retaining pin, which is made of nylon. It goes into this hole here. That nylon retaining pin applies a little bit pressure on the lower punch shank so that the punch doesn't turn during compression. And this piece here is the lower punch pull down cam. This plug here is used to close the opening that we use to install the lower punches. Once the installation of the lower punches is completed, that hole there has to be plugged. Otherwise, during running of the machine, the lower punches may fall down through that opening, and it would be a dangerous accident. It's very important to close that opening. And the cam here is the weight fill cam. That is the cam that actually goes up and down when we turn the weight adjustment knob. And you can see right now the cam is going up. That means we are reducing the fill weight, the weight of the powder that goes into the die. We are actually decreasing the volume of the die cavity by raising the cam up. If we go the other direction, now the cam is going down and we are increasing the volume of the powder that would fill into the die. That is how you adjust the weight of the tablet. You turn the power on, and these are the controls for the turret actually running the machine, and these are the controls for the force, variable speed force feeder. This is the emergency knob, and when you hit this, the trip light will go on, and whenever you unlock the emergency, you have to press the reset button first before you can switch the machine on or the force feeder on. This here is the stop. This is the start. This is the potentiometer to control the turret speed. When this is on, the light will be on here. Same thing for the force feeder. Stop, start, potentiometer for speed control, the light for the motor on. And the force feeder is independent of the turret speed. So it is not linked to the turret. You have control on the force feeder independently. This is the electrical main switch. That is the on-off switch. And this here is the electrical inlet into the machine. That is the electrical supply. This knob here is the weight adjustment knob. That is the knob you turn clockwise or anti-clockwise to adjust the weight of the powder that fills into the die cavity. This here is the adjustment for the pre-compression force, there is a knob at the end of the handle here, and that knob can be turned clockwise or anti-clockwise, and then the handle will be moved back and forth like this to adjust the pre-compression force. This knob here is for adjustment of the compression force, which means it is an adjustment for the tablet hardness. By turning it clockwise or anti-clockwise, you can increase or decrease the compression force and consequently the tablet hardness. This here is the hand wheel, which is enclosed in an acrylic safety guard, and the hand wheel has a handle and it has a clutch mechanism also. So when the machine is running, the clutch will not be engaged and the hand wheel does not turn. If it turns by any chance, the safety guard will keep it inside, so it would be safe for the operator. When you want to turn the machine by hand, you press the hand wheel inside, so the clutch gets engaged, and then you can turn the wheel to turn the turret by hand. This here is the safety interlock for the acrylic guard. Each acrylic guard has one safety interlock. When you bring the door down, it is going to push this safety interlock inside. That is when it will provide the contact, circuitry contact inside. And this assembly here is meant for guiding the upper punch as it travels down the upper punch cam track. It prevents the upper punch from bouncing up and down during its descent on the upper punch cam track. This here is the upper pre-compression roll carrier. That is the one that carries the pre-compression roll on a pre-compression pin. This here is a part of the instrumentation package which does not come with the machine unless you buy the instrumentation package. This is the pre-compression load sensor that will monitor the pre-compression force during the running of the machine. This here is the pre-compression roll that turns, and that is the one that applies pressure, pre-compression pressure. That is the pre-compression roll. And here is the lower pre-compression roll right here, which is connected to a mechanism inside that can raise this pre-compression roller up or down when we move the pre-compression adjustment handle back and forth. This Teflon anti-leak strip is actually installed in a groove inside the platform of the feed frame base, and that Teflon strip actually scrapes the side of the turret to prevent to scrape off any material that is sticking to the side of the turret, and it prevents leakage of the powder from the die table onto the platform of the machine. This is the back side of the machine. I will show you the parts here. This is the upper compression roll carrier. This here is the instrumented compression pin for the upper row. So this will give you upper punch compression force during running. This again is a part of the instrumentation package. The machine itself does not come with instrumented compression pin unless you buy the instrumentation package. This here is the upper compression roll. This bracket here is again a part of the instrumentation package. It is a bracket to hold the two proximity sensors which are part of the instrumentation. This here is the nozzle for dust collection from the die table. If there is any excess powder on the die table, this nozzle, which is actually connected inside to a dust collection tube, it will remove that dust. And this here is the lower compression roll. And this here is again a part of the instrumentation package. This is a box that contains all the amplifiers to amplify the signals from the load cells. The compression, pre-compression, and ejection load cell signals go in here and they're amplified, and from here they go to the computer, which has a data acquisition card that processes that data and gives you the compression, pre-compression, ejection forces during running of the machine. This side is the left side of the machine, and it has an ejection chute where after the tablets are ejected here, they will come on this chute and they get collected into your container. This chute has some holes here, and it is connected to a vacuum outlet. As the tablets are passing on this chute, any loose dust sticking to the tablets would be removed by this vacuum here. This white bar here, which is attached to the gravity feed frame, is called ejection blade. That is the one that when the tablets are ejected, they hit this bar and they're guided to this ejection chute. And here there is a fan which is used to cool the motor inside. And there is another vent here to vent out any of the heat that gets generated inside the machine. This here is the ejection cam. In this particular case, this ejection cam is an instrumented cam. So, it has a unique design for instrumentation, but if it is not an instrumented cam, it would be all plain without any slots or grooves or anything on that. This is the cable that is coming from the instrumentation part of the cam that goes to the amplifier box. And this part here, which extends quite a bit, is the lower punch pull down cam. I have shown this part to you before also. And on this lower punch pull down cam, there would be stamped on the outside the depth of that cam, because these cams, the lower punch cam, they're available in different fill depths. This is the dust collection outlet, which you would connect to a central vacuum in your place or a simple vacuum cleaner or any dust collector. This actually is connected inside by a hose to both this dust collection nozzle as well as this tablet ejection chute. When you receive MiniPress II from GlobePharma, it is shipped to you in a wooden crate and the machine is bolted to the bottom plank of the crate. You open the crate, remove all the side planks and then loosen the bolts and remove the bolts from the machine that are holding to the bottom plank. After removing the bolts, the machine has to be lifted, actually must be lifted by a hydraulic lift, like a forklift. Please do not attempt to lift the machine manually. The machine weighs about 400 kilos and it can cause bodily injury to anybody attempting to manually move the machine. If you have bought a cart from us, which is this one here, this cart is designed to hold the weight of this machine. The capacity of this cart is 2,500 pounds. If you have not bought the cart from GlobePharma, please make sure that whichever cart you're using is rated for holding at least 2,500 pounds. This cart is made of stainless steel and there are supporting braces underneath the top shelf to hold the weight of the machine. The cart also comes on 4 casters and a floor truck lock so that you can move the machine anywhere you want and also lock the machine to the floor when you're ready to use. The machine has a cover at the top, and once you remove this cover, there is an eye bolt here, and that eye bolt has to be used to tie a nylon string to a hydraulic lift, and then you can lift the machine. Before the machine is placed on an appropriate table, we have to drill 4 holes onto the top shelf of the table. Inside the machine, the bottom plate, which is a solid steel plate, has 4 holes, one at each corner of the machine. Through those holes and the holes drilled in the cart, we tighten bolts. So the machine would be fastened to the table by 4 bolts. That is very important to do so that the machine does not move during actually the compression process. If you purchased the table from GlobePharma, we pre-drill those holes on the table so you do not have to drill those holes yourself. But when the machine comes to you, actually the machine comes in the wooden crate and the table is packaged separately and it comes as a separate box. You place the machine on the table, align the holes, you can open the front door, all the doors actually, and put the bolts through the holes and tighten them. Then the machine is secured to the table. If you want additional safety, you can actually bolt the machine itself to the floor if you need to do that. But this machine is supposed to be a portable machine, so you can leave it on the cart with wheels also. I would like to emphasize on some of the cautions you have to observe while installing the machine and while running and cleaning the machine. Number 1, the main switch must be turned off and electrical cord unplugged before cleaning or working on the machine. Number 2, do not operate the machine without the safety guards in place. Third, do not move machine manually. Bolt machine to table and, if necessary, bolt table to the floor. Especially while cleaning, make sure the machine is not plugged. Make sure it is, otherwise, some people have punched their fingers while cleaning the machine and switching the machine on. Before cleaning, always remove the tablet tooling so the turret is free of the punches and all that. And also follow all the electrical specifications given in the instruction manual, which is very well illustrated, and make sure the cord, the plug, and the outlet on the wall, they all meet those electrical specifications. Once the machine is installed on the table, this is how it would look. Now I will show you how to tool the machine with punches and dies. The first thing to do is to install the die. Then we will install the lower punch, followed by the upper punch, and then we will install the feed frame and the hopper. To install the dies, open the acrylic doors. Make sure during this phase there is no electrical connection to the machine. And this is the die table, and there are 10 die pockets here because this is a B-tooled 10-station machine. I have already installed 5 blank dies in the alternating die pockets because we don't need to install all of the 10 stations to demonstrate running of the machine to you. So I will install 5 stations only on this machine. The remaining 5 would be blank. There are 2 tools here which are very useful when installing the dies on the machine. This tool is called actually a donut. This actually guides the die into the die pocket so that the die does not go in a crooked angle. This is also called a die alignment tool. This is another tool that is useful for cleaning the die seat in the die pocket. That is, this is the die seat where the die is going to sit. When the machine comes to you, of course, the die pockets are clean and you don't have to use this to clean the die pocket. But if you have been using the machine and some powder gets accumulated on the die seat, and then if you don't clean, the dies may not sit properly in the die pocket. So in that case, you take this tool and take it to the machine and go inside, put it inside the die pocket, and then just turn it like this. So, and then take it out, and these blades here would scrape off any excess powder that is on the die seat, and then you can brush it off or vacuum it off. In order to remove the die lock screws, it is more convenient if you turn the turret by hand and bring the die lock screw into this position so that you will have easy access to remove it using an Allen wrench. Let me show you one. Turn the hand wheel clockwise. Now with the Allen wrench, you loosen the die lock screw first, and then remove it all the way. Screw comes flush with the side of the die table. You don't have to remove it out completely, but make sure it doesn't protrude out too much. Otherwise, when you turn the turret again, the die lock screw might scrape against this Teflon scraper here. Once that is done, now we will install one die using the die alignment tool. This is the die alignment tool, and this is one of the dies, and you put the die alignment tool on the die table, not on the die pocket right now, and then insert the die in there like that, and then you can slide it onto the die pocket. You can lift the die alignment tool a little bit to see the die underneath, and then the die falls into the die pocket. Then you can use the small brass rod to tap the die so that the die surface is flush with the surface of the die table. Then you have to tighten the die lock screw. Now we will install the lower punch. To do that, we bring station number 5 to line up with the hole through which the lower punch is inserted into the lower punch bore. And after you do that, after you insert the punch, lift it up, hold it with your finger so that it doesn't drop by itself. Then insert this nylon lower punch retaining plug into the hole that is supposed to hold that plug, and then move the spring-loaded leaf spring and tighten that with screwdriver if necessary. You want to put just a little bit pressure, not too much, and then you move the die table forward by turning the flywheel. Then you pull the punch down onto the lower table. And once that is done, we can close the takeoff piece, put it back, and put the guards back, and the machine would be ready to run. I will not put the takeoff piece back right now because I want to show you how to install non-round shaped tooling, like caplet shape, oval shaped tooling. There, the installation of the die is a little bit different, so I want to show that to you also before we completely finish the tooling. Now I will show you how to install shaped tooling, like oval shaped or caplet shaped tooling. In this case, first insert the keyed punch, upper punch, into the upper punch die bore, making sure that the key goes into the keyway, and then you hold the die above the die pocket and let the punch tip go into the die like this, and then let the die go inside. Then you can pull. While it is like this, it is better to tighten the die lock screw at this point. That way, the die wouldn't move when we remove the upper punch. Just hand tighten, and you can use a torque wrench with a preset torque to tighten the die lock screws. About 14, 15, 16 pounds of foot-pounds of torque is enough to tighten the die lock screws. If you are using an Allen wrench like this, just tighten it with hand so that it is tight enough. Then you lift the upper punch up, and then you can move the turret, making sure that the upper punch head enters the cam track, and bring that station in line with the hole through which we will insert the lower punch. This is the lower punch. And when you insert the shaped lower punch, make sure the punch tip is lined up to enter the die. You have to turn it little bit to make it enter the die pocket. Now the lower punch tip has entered the die by turning it back and forth a little bit until the tip of the lower punch lines up with the angle of the die cavity. Then you push it up, and the punch tip, you can see it has come out, just to show that it has entered the die cavity. Now you can turn the machine a little bit until this clears that hole, and you can pull the punch down, and the lower punch retaining plug is already in there. Just put the spring leaf on there so that it puts pressure on that retaining plug. The turret guard has been installed after we finished tooling the machine. The installation of the turret guard has been explained to you before. Now we will install the gravity feed frame. This is the gravity feed frame, and this is the scraper bar that scrapes the excess powder after the die is filled with the powder, and this little spring loaded blade keeps tension on the scraper bar so that the scraper bar stays in contact with the turret surface. This can be tightened or loosened, because there is a screw here to keep just enough tension on the scraper bar to scrape the excess powder, but not tight enough that it scrapes the turret surface. And this here is made of Delrin, which is a FDA approved plastic. This is the ejection blade. There are two screws with slots here. You can adjust the height of this by adjusting those screws. This should be pretty much touching the turret surface, but there should be maybe 1 millimeter gap or something. This is where, when the tablets are ejected, they touch this blade, and this blade guides them to the ejection chute. You place the feed frame on the feed frame base, and then there are two nuts here, thumb nuts. You tighten the feed frame by hand. Now the feed frame is installed. At this point, it's a good idea to turn the machine by hand using the hand wheel or the flywheel to make sure that everything is smooth. If you made any mistake in installation of the tooling, you will be able to catch it when you do this little hand run. Let me do that. At least turn 1 or 2 turns completely. Everything looks smooth here. So we are now ready to install the hopper, put the powder, and make some tablets. We will close this door, and we close all the acrylic doors. Now we will install the hopper, but let me show the hopper to you before I do that. This is the hopper. If you can see that the stem is at an angle, that is the one for gravity feed frame. There is a ring here with 3 thumb screws, and this ring is tightened against the body of the hopper with set screws. There is one here, and one here. And this ring can be moved up or down so that when you put it in the feed frame, there is proper clearance between here and the die table. Now you take the hopper, remove the top cover, and turn the stem like this, and make sure this dip here is facing here, and drop the hopper in position. Then we put the cover back on. Now we can put powder into the hopper and we can run the machine. This is the container in which we will collect the tablets, and this is the powder blend. Now we load the powder into the hopper. Now we put the lid on the hopper, and now we are ready to run and roll. Before I start making the tablets, I would like to make one quick point. Make sure the clearance between the hopper stem and the surface of the turret is maybe 3 to 4 millimeters, something like that, depending upon the flowability of your blend. The criterion is that there should be powder in all the pockets of the feed frame at all the time, but no excess powder should be overflowing the feed frame. If you need to adjust that height, remove the top cover, and I showed you before, there are 3 thumb screws on the hopper ring. You can adjust those to adjust the clearance in the hopper, also to change the angle of the hopper. Those things you can adjust to have appropriate flow. The first thing we do is make sure that the tablet hardness adjustment is all the way at the low level. That way we don't jam the machine or something like that. So I turn the hardness adjustment knob clockwise to decrease the hardness, which is decreasing the compression force. Then we will run the machine by hand and see if there is any compression force at all to make a tablet. If we make a tablet, we will weigh the tablet to the weight, to your target weight, and then if everything is okay, then we can run the machine by electric power. Until then, we don't switch on the machine. See, now the tablets are not compact at all. It is pretty much a loose slug of powder, which means I need to increase the hardness. I turn the knob to counterclockwise to increase the hardness. Now I can feel the pressure, so we must be making a tablet. You can hear the tablets coming out. This exercise also serves as a cautionary step before turning on the machine. With the powder, the machine is turning smooth. There are no problems. So now we are ready to switch the power on and run some tablets. I switch the power on. See, the trip lamp is on. You press the reset button. Okay, we have to unlock this, which is the emergency button was pushed down. So you have to unlock it, then press the reset. The trip lamp is off now. We are ready to run the machine. Have to start the motor first. You can see the light on. That is for the turret. Now we can turn the potentiometer to run the machine. Right now it is running at a slow speed. This is how the tablets are. I will increase the hardness a little bit more and show you how the tablets look under more compression pressure. I increased the hardness. And the tablets are quite hard when we break them, and you can increase the hardness more if you want. Of course, you will be checking your disintegration time, friability, and all those things to make sure your tablet has enough hardness but not too hard so that it doesn't disintegrate, and the friability should be low also. And we can run the machine at fast speed also. That is the fastest it can run, which is 36 RPM. You can see here how well the dice are scraped to maintain the tablet weight. And before, you have seen in the feed frame, the powder is there in all the pockets. You see, as you see that there is not that much powder in the third pocket of the feed frame, but the first, second, and the fourth pockets have enough powder, so that may be enough. You have to check the tablet weights, and then if there is too much variation in the tablet weight, then adjust the powder hopper so that there is powder in all the pockets. That is especially so if you are running the machine at a high speed, because the die pocket doesn't get that much time to fill with powder, so it is better to have powder in all the pockets. This knob is for adjusting the tablet weight. When you turn this knob in a clockwise direction like this, you are going to reduce the tablet weight. And if you turn the knob this way, counterclockwise, you increase the tablet weight. And this here is for the pre-compression, and this knob can be turned clockwise or counterclockwise. When it is clockwise, turned all the way clockwise, and then if you do this, you are decreasing the pre-compression pressure. But if you turn this knob counterclockwise all the way, and then you move this, you are increasing the pre-compression compression pressure. And this knob here is for tablet hardness. If you turn this clockwise, you are going to decrease the compression pressure, and correspondingly you will decrease the tablet weight. If you turn this counterclockwise, you are going to increase the compression pressure, and correspondingly you are going to increase the tablet hardness. There is one caution here. Do not push the hand wheel inside while the machine is running. If you have this guard on, of course you wouldn't be able to push the hand wheel inside while the machine is running, because then there is a clutch, and that can really cause a problem. Make sure you have the guard on while the machine is running, because you can see, even though the hand wheel has a clutch, it is still moving, and we don't want it to harm anybody. And these knobs, actually they come off just like that, and you can put it back on just by sliding it on there. When you want to remove this door, you have to remove the hand wheel, you have to remove the two knobs, and then you can open the door. Now I will show you the details of the force feeder, how to install it, and how to use it to make tablets. We have already removed the gravity feed frame and the gravity hopper. Now this is the force feeder. The gears of the force feeder are in here, and this is the connection to the force feeder drive shaft, which is this one here, and this is where the hopper stem goes, and this is the plate which actually controls the flow of the powder into the feeder. And this plate here has flat side, and also it has a side where there are several dimples here. Okay, that is the side that goes underneath. I mean, that is the side that is down. And here, if you can see, there is a little spring loaded ball there, and this plate, when it goes, it locks into that spring loaded ball, locks into one of those dimples. So you can adjust the height of this by pulling up or pushing down. And if you see, there are stainless steel paddles here, 1 and 2. They rotate in the opposite directions, and they force the powder into the die pocket. And this one is the ejection blade, just like we have one on the gravity feeder. And this is a small plastic guide to guide the excess powder back into the feed frame. This one here is the scraper blade to scrape the excess powder from the die, and it is spring loaded, so it doesn't scrape the surface of the die table. Now there is an acrylic cover here to keep the powder inside the feeder. Now we will install this. Just like the gravity feeder, the same two knobs will be used to fasten the feed frame to the feed frame base. Just lift the feed frame a little bit and see where the threaded hole is, and then you can tighten this, and this knob goes here. You tighten both. Once that is done, you lift this locking sleeve, and there is a slot here in the drive shaft where this has to fit. This you can turn by hand to match this, then you can slide that into that slot and then slide the locking sleeve down. Now the force feeder drive shaft is engaged with the force feeder. Now we will put the force feeder hopper, close the doors, put the powder, and try making some tablets. This is the force feeder hopper. As you can see, the stem is straight here, whereas in the gravity hopper, it is kind of at an angle. So this one now goes here, and the stem goes into this spout here. Yeah, now it is completely fit inside this. Now we can close the other two acrylic doors. Now we are ready to put the powder and run the machine. Now the machine is set with the force feeder and the force feeder hopper. We switch the machine on and press the reset. Press the start button for the turret. Press the start button for the feeder. You can see that the powder is in the feed frame, and it doesn't look like it is packed, or it doesn't look like it is too low there. It looks like it is a pretty good flow there. Here are the lower punch pull down cams of different fill depths, and this is the ejection cam for MiniPress II. This cam has a fill depth of 10 millimeters, and this has a fill depth of 12 millimeters, and this has a fill depth of 20 millimeters. And those numbers are stamped on the side of each of the cams. This is the ejection cam, and it is the regular cam, not instrumented. The instrumented cam will have slots and other design for installation of strain gauges. When you need to make a very small tablet, you would use a shallow cam, and you want to make a big tablet, you would use a deep fill cam. And if you want to change the cam on the machine, underneath the middle plate inside the machine, there are 3 bolts. You have to remove the bolts and take out the other cam and install the new cam. And it is explained in the manual very much in detail. I hope this demonstration of MiniPress II is useful to you, and please follow all the instructions in the operation manual for maintenance of the machine. There is very little maintenance, but there are a couple of grease nipples, so please grease the machine once a week or something like that, depending upon how much you use. We also have another machine which is MiniPress I, which is a simpler machine than this. That machine comes with only one option for the turret, that is electroless nickel plated 10 station B, turret B like boy. And the major difference between the two machines is, in MiniPress I there is no pre-compression feature and there is no force feeder. It works only with a gravity feeder and only with major compression. There is no pre-compression at all. But the machine works very well, and it is a less expensive machine if you don't need all these features. That will be a separate DVD, and if you need that, please let us know.